At the heart of our Milky Way galaxy, hidden behind clouds of gas, dust, and the countless stars that crowd the galactic core, lies an object so strange that for most of human history, we had no idea it was there. It is invisible to our eyes, silent most of the time, and yet unimaginably powerful. This mysterious presence is known as Sagittarius A asterisk, a supermassive black hole with the mass of more than 4 million suns. Unlike the roaring black holes at the centers of active galaxies, Sagittarius A asterisk is surprisingly quiet, almost shy in comparison. But its quietness is deceiving, for beneath the surface lurks a storm of extreme gravity, magnetic fields, and energy flares that push physics to its limits. To understand the story of Sagittarius A asterisk, we must first imagine the challenge that confronted astronomers for centuries. Even after telescopes had been invented and scientists had begun mapping the heavens with precision, the very center of the Milky Way remained hidden. The sky toward the constellation Sagittarius was a puzzle, a wall of brightness and darkness that resisted clear interpretation. When astronomers turned their telescopes toward the galactic center, they encountered not an open window, but a barrier. Stars were packed together so tightly that they blurred into one another, while thick lanes of interstellar dust cut across the sky like dark rivers. This region, now called the galactic bulge, is one of the densest and most chaotic places in our galaxy. Hundreds of billions of stars crowd together, their light mingling into a confused glow. To the naked eye, the Milky Way appears as a pale streak across the night sky. At first glance, it might resemble a soft cloud, but in truth that hazy band is made of countless stars so densely packed that their light blends into a single luminous stripe. The glow becomes brightest near the galactic center, but it is also there that the darkness becomes most pronounced. This darkness is not empty space. It is the shadow of dust. Scattered between the stars are immense clouds of interstellar material, made of carbon, ice, and microscopic grains of rock. Though individually tiny, these particles are spread across vast regions, and together they form a fog that blocks and scatters visible light. For much of history, this dust was an insurmountable barrier. Early telescopes, like our eyes, depended on visible light, and visible light is precisely what interstellar dust blocks most effectively. When astronomers peered toward Sagittarius, they saw nothing but confusion, a mixture of glowing stars and dark streaks that hid the true core of the Milky Way. The stars closer to us were visible, but beyond them, the light was lost. The center of the galaxy lay veiled behind a curtain drawn across the sky. This obscurity led to centuries of misconceptions. Without a clear view, early scientists assumed the galaxy's structure was simple and perhaps centered on the sun itself. In the 18th century, the astronomer William Herschel attempted to map the Milky Way by counting stars. He recorded the number of stars visible in different directions and used those counts to infer the galaxy's shape. But he had no way of knowing that vast clouds of dust were hiding most of the stars in the galactic center. His map showed fewer stars in those directions, and so he concluded the galaxy was shaped unevenly, with the sun close to its center. In reality, the missing stars were simply hidden from view. Only in the 20th century did the picture begin to change. Scientists realized that to see through the dust, they would need to look with new kinds of eyes. Light exists across a spectrum, from long radio waves to short X-rays, but our vision captures only a narrow slice in the middle. Dust is highly effective at blocking visible light, but other kinds of light, such as infrared and radio waves, pass through more easily. With instruments designed to detect these invisible forms of light, astronomers could finally peer into the galactic bulge and glimpse what lay beyond. The story of this breakthrough begins almost by accident. In the 1930s, when a young engineer named Carl Jansky was investigating sources of static that interfered with radio communications. Working at Bell Labs, he built a large rotating antenna to track radio noise across the sky. He discovered that while some of the static came from nearby thunderstorms and distant lightning, there was another source that repeated on a cycle not tied to the sun, but to the stars. Each day, The signal arrived 4 minutes earlier, exactly matching Earth's rotation relative to the heavens. This meant the signal was coming from space, and its direction pointed straight toward the center of the Milky Way. Jansky's discovery was the birth of radio astronomy, the first time humanity had detected radio waves from beyond the solar system. At the time, few astronomers paid attention. The world of optical telescopes dominated, and Jansky's equipment was dismantled once Bell Labs moved on to other projects. But his finding planted a seed. A few years later, Grote Reber, an amateur radio engineer, built a dish antenna in his backyard and confirmed Jansky's results. Reber produced the first radio map of the sky, and the brightest signal of all came from Sagittarius, the same direction Jansky had noticed. In the decades that followed, radio astronomy grew rapidly. Larger, more sensitive antennas were built, and a new picture of the galaxy emerged. Objects invisible in visible light were revealed in radio. Supernova remnants, gas clouds, and even distant galaxies glowed with radio energy. And at the very center of the Milky Way, a compact, powerful source stood out. Astronomers named it Sagittarius A. It was clear that something strange was buried in the heart of the galactic bulge. Something small in apparent size, yet powerful enough to outshine entire regions in radio waves. The discovery was tantalizing, but not yet conclusive. Radio telescopes revealed the presence of something unusual, but they could not show exactly what it was. To learn more, astronomers would need sharper instruments and new techniques to pierce the veil of dust. The coming decades would bring those tools, and with them, the first real glimpses of the monster hidden at the center of our galaxy. For now, all they knew was that the galactic bulge was not empty. It was a crowded, dynamic place filled with stars, dust, and strange signals. The curtain had been lifted slightly, and beyond it, something extraordinary was waiting to be revealed. The universe is full of puzzles that resist easy solutions, and among them, black holes stand as some of the most baffling. To grasp why Sagittarius A* is so extraordinary, we need to zoom out and think about the life cycle of stars, the quiet architects of cosmic history. Stars are born in dense clouds of gas and dust, spending millions to billions of years fusing hydrogen into helium, generating light and warmth. But even these seemingly eternal beacons are not immune to the relentless ticking of cosmic time. When massive stars reach the end of their fuel, they collapse under their own immense gravity, creating either neutron stars or, if they are massive enough, black holes. These stellar black holes are common, sprinkled across galaxies like invisible seeds. They are heavyweights, but compared to what sits at the heart of the Milky Way, they are mere pebbles. Somewhere along the cosmic timeline, something different happened. Instead of a black hole a few times the mass of the Sun, Sagittarius A* emerged with the weight of 4 million suns compressed into a region no larger than our solar system. The origins of such monsters remain a mystery. Did they grow slowly, feeding on gas, stars, and unlucky wanderers for billions of years? Or were they born large, forged from the direct collapse of massive clouds of primordial hydrogen in the early universe? Scientists continue to debate these questions, but one thing is certain. Sagittarius A* has shaped the destiny of our galaxy since its earliest days. It is not merely a passive observer but an active participant, its gravity binding the stars of the Milky Way together in a dance that has lasted for eons. To understand the true nature of Sagittarius A*, astronomers had to get creative. Black holes cannot be seen directly, since no light can escape their grasp. Instead, scientists look for indirect signs, like detectives searching for clues to a crime that has left no witnesses. The most compelling evidence came from watching the orbits of stars near the galactic center. For decades, teams of astronomers tracked stars like S2, a bright star that whips around the invisible mass at the core once every 16 years. The path of this star and others revealed a central object so dense and compact that no other explanation made sense. It had to be a supermassive black hole. Sagittarius A* does not shine like the blazing stars around it, but it leaves fingerprints in the universe. When gas and dust fall toward it, they form an accretion disk, a swirling whirlpool of matter heated to extreme temperatures. For a brief time, the gas glows with fierce energy before crossing the event horizon, the boundary from which no light or information can escape. Yet compared to the ferocious black holes in distant galaxies, Sagittarius A* is relatively quiet. Some call it a sleeping giant, waking only occasionally when a star or cloud wanders too close. In those moments, it flares, releasing bursts of radiation that ripple across the cosmos. But the most breathtaking achievement came in 2022, when humanity, for the first time, saw the unseeable. Using the Event Horizon Telescope, a global network of radio observatories linked together to act as a planet-sized lens, scientists captured the first direct image of Sagittarius A star. What emerged was a glowing golden ring encircling a dark shadow, the silhouette of the black hole's event horizon. It was a moment of awe, not only because of the image itself but because of what it represented. Proof that even the most enigmatic objects in the universe can yield their secrets to patience, collaboration, and ingenuity. The picture was not just of a black hole. It was a portrait of gravity itself, bent and curved in ways Einstein had predicted over a century ago. Seeing Sagittarius A* in this way changed the story. For decades, black holes had lived in the imagination, painted through mathematics and indirect evidence. But now there was something tangible, an image that anyone could look at and wonder about. And though the picture was fuzzy, a blurred ring of light, it held within it a universe of meaning. It confirmed that general relativity holds true even in the most extreme environments, where gravity warps space and time almost beyond recognition. It reminded us that even from 93 million miles away, tethered to our small planet, we can stretch our vision to the center of the galaxy and glimpse a shadow that has existed for billions of years. Yet Sagittarius A* is more than an astrophysical curiosity. It is a key to understanding ourselves, the history of our galaxy, and the fate of the cosmos. Every star you see in the night sky, including our own sun, is caught in its gravitational embrace. Without the anchoring presence of this supermassive black hole, the Milky Way might look very different, perhaps looser, less organized, or even unable to hold itself together over cosmic timescales. In this sense, Sagittarius A* is not only the heart of our galaxy but its architect, shaping its structure and evolution across billions of years. Still, mysteries remain. How exactly did Sagittarius A* grow so large? Why does it appear so quiet compared to other supermassive black holes, some of which unleash jets of energy that blaze across intergalactic space? And what role will it play in the far future of the Milky Way? As telescopes sharpen their vision and simulations grow more powerful, we inch closer to answers. But perhaps the true wonder lies in the questions themselves, in the recognition that we live in a galaxy whose heartbeat is a shadow in space, invisible yet essential, terrifying yet beautiful. The story of Sagittarius A* is not just a tale of astronomy. It is a reminder of human persistence. For centuries, we gazed into the Milky Way without knowing what lay at its center. Now, through decades of work, we have peeled back the darkness and seen its hidden engine. In doing so, we discovered not only the black hole but a reflection of ourselves, the ability to push against the limits of the possible, to seek understanding even in the deepest void. And as we continue to study this cosmic giant, we will carry forward the same spirit of curiosity that brought us this far, knowing that the center of our galaxy holds not only a black hole, but a mystery as vast as imagination itself. If the image of Sagittarius A* captured in 2022 felt like peering into the very heart of mystery, the science surrounding it deepens the enigma even further. The dark shadow we saw, encircled by that glowing ring, was more than just a picture. It was a confirmation that black holes are not just theoretical constructs or mathematical curiosities, but tangible forces shaping the cosmos. Yet to truly appreciate what lies at the center of our galaxy, we must explore the strange physics that defines it. a physics that challenges even our most fundamental understanding of reality. At the very edge of Sagittarius A asterisk, there exists a boundary known as the event horizon. This is the ultimate point of no return, a threshold that separates the universe we can know from the unknowable abyss beyond. Cross this line and all paths lead inward. Even light, the fastest thing in the universe, cannot escape once it has passed through. To an outside observer, matter falling toward the black hole seems to freeze at the horizon, time itself slowing to a crawl under the immense pull of gravity. But from the perspective of that matter, time continues as usual, carrying it inexorably inward. The duality is mind-bending, an illusion created by the warping of space-time itself. This warping was foreseen by Einstein more than a century ago. His theory of general relativity predicted that gravity is not a force pulling objects together in the traditional sense, but rather the bending of the very fabric of space and time. A star warps this fabric slightly, our sun a bit more. But Sagittarius A asterisk bends spacetime so violently that it creates a well with no bottom. Inside, the laws of physics as we know them break down. The singularity, the heart of the black hole, remains hidden behind the event horizon, a place where density becomes infinite and the familiar rules of nature dissolve into mystery. And yet, the universe does not end at this shadow. Paradoxically, black holes can be among the most luminous objects in existence. While nothing escapes from inside the event horizon, the material swirling just outside it is accelerated to incredible speeds, colliding and heating to millions of degrees. It radiates across the electromagnetic spectrum, from radio waves to X-rays, briefly outshining entire galaxies before vanishing. Sagittarius A asterisk is relatively quiet compared to its kin, but even in its slumber, it occasionally sends out flares that light up the center of the Milky Way. These flares are like whispers from the abyss, reminders that the black hole is not silent, merely patient. To astronomers, every flare is a clue. Instruments like NASA's Chandra X-ray Observatory and the Very Large Telescope in Chile have recorded these bursts, capturing data that reveal how matter behaves in the most extreme environments. Some flares may be triggered when small clumps of gas or even asteroids fall inward, torn apart by tidal forces before being swallowed whole. Others may represent magnetic fields twisting and snapping, releasing energy in sudden bursts. Each flare is a fleeting glimpse of the violent processes unfolding at the threshold of oblivion. Beyond the event horizon, the questions become even stranger. What happens to information that falls into a black hole? Physics suggests that information, the details about matter and energy, should never be destroyed. Yet, once something passes beyond the horizon, it seems lost forever. This puzzle is known as the black hole information paradox, and it has driven some of the greatest minds of modern physics to the edge of imagination. Stephen Hawking proposed that black holes may slowly evaporate through a process now called Hawking radiation, leaking tiny amounts of energy back into the universe over unimaginable timescales. If this is true, even Sagittarius A asterisk, massive as it is, would not be eternal. Trillions upon trillions of years from now, it could evaporate away into nothingness. But for now, it remains steady, anchoring the galaxy around it. The stars nearest to Sagittarius A asterisk continue their graceful, perilous orbits, some swinging so close that they travel at a few % of the speed of light. These stellar motions have provided some of the most precise tests of relativity ever conducted. When Star S2 approached its closest pass in 2018, astronomers observed the predicted redshift in its light, evidence of time itself being stretched by the black hole's gravity. Observing these stars is like watching a cosmic ballet choreographed by gravity, with Sagittarius A asterisk as the hidden conductor. Still, perhaps the most extraordinary aspect of Sagittarius A asterisk is what it symbolizes for humanity. Across cultures and throughout history, the center of the galaxy has been a place of myth and meaning. Ancient civilizations looked up at the Milky Way and saw pathways to the afterlife, rivers of souls, or the body of a cosmic serpent. They could not have known that at its heart lay a black hole, but their intuition placed significance where science would later uncover truth. Today, our myths are framed in mathematics and observation, but the sense of awe remains the same. We are creatures who look upward, who wonder about the unseen, and who strive to illuminate the darkness. The journey to understanding Sagittarius A* is far from over. Future instruments like the next generation of the Event Horizon Telescope, the James Webb Space Telescope, and even planned space-based observatories will push our vision deeper. We may soon see sharper images, capturing not only the glowing ring of light, but also the magnetic fields and turbulent structures around it. Computer simulations, powered by supercomputers, already allow us to visualize what happens near a black hole in astonishing detail, turning equations into swirling disks and flickering jets. Each advancement brings us closer to answers, but also to new questions, because black holes are not only laboratories of physics, they are windows into the unknown. And so, Sagittarius A* sits in silence, 4 million times the mass of our sun, a shadow at the galaxy's heart. It has been there since the Milky Way was young, shaping its stars, sculpting its spiral arms, and binding us all in a shared gravitational embrace. It will be there long after our sun has burned out and our planet has gone cold. To study it is to look both outward and inward, to recognize that the same laws governing the motions of galaxies also govern the beating of our own hearts. In its darkness we find reflection. In its mystery, we find meaning. When we speak of Sagittarius A*, it is easy to imagine it as a solitary presence, an isolated giant, hidden in the shadows at the center of our galaxy. Yet black holes are rarely solitary in their influence. They exist as parts of larger ecosystems, interacting with the stars, the gas, and even the dark matter that surrounds them. To understand Sagittarius A* fully, we need to think not only about the black hole itself but also about the cosmic environment in which it lives. The galactic center is not a quiet place. It is a region dense with stars, clusters, and clouds of gas that weave together a complex tapestry of matter and motion. Some of these stars are young, burning brightly and forming in clusters near the black hole. Others are ancient, relics from an earlier age of the Milky Way. Together, they circle Sagittarius A* in a dizzying gravitational ballet. The very existence of young stars so close to such an intense gravitational source is a puzzle in itself. Conventional theories suggest that the tidal forces of the black hole should prevent new stars from forming nearby. And yet somehow they do. Astronomers call them the paradox of youth. Stars that appear to have been born in a region where their very creation should have been impossible. These stars are more than curiosities. They are test particles in an experiment written by nature. Their orbits allow scientists to measure the black hole's mass with exquisite precision, and they provide an opportunity to watch relativity at work in real time. Each pass, each orbit, is a data point that refines our picture of the invisible giant at the galaxy's heart. Over decades, astronomers have come to know these stars almost personally, tracking their arcs and predicting their paths like old friends. But the galactic center holds even greater mysteries. For one, there is the question of dark matter, the unseen substance that outweighs all visible matter in the universe. Some theories suggest that the innermost regions of galaxies, including the heart of the Milky Way, may be dense with dark matter. If true, then Sagittarius A* sits not only among stars and gas but also within a halo of invisible mass, influencing its growth and behavior in ways we cannot yet fully measure. Understanding this relationship could help unravel one of the most profound puzzles in modern cosmology. What is the true nature of the matter that shapes our universe yet cannot be seen? Sagittarius A* also has a potential future companion, another supermassive black hole. In about 4 billion years, the Milky Way is expected to collide with the Andromeda Galaxy, a cosmic merger that will reshape the night sky. When that happens, the central black holes of both galaxies will spiral toward one another, eventually fusing into an even more massive singularity. The thought of two galactic hearts colliding is staggering, a reminder that black holes are not static monuments but active participants in the ongoing drama of cosmic evolution. The gravitational waves released in such a merger would ripple across the universe, echoes of a union on a scale beyond comprehension. Even in its quieter state today, Sagittarius A* may have had a more turbulent past. Observations suggest that millions of years ago, it might have been far more active, feeding greedily on gas and dust, sending out jets of radiation that left imprints still visible in the galaxy. Vast structures known as the Fermi bubbles, enormous lobes of high-energy particles extending above and below the plane of the Milky Way, may be relics of such an outburst. If true, then the black hole at our center has not always been a sleeping giant. It has awakened before, and it could awaken again. The possibility of reawakening brings us back to the present, where astronomers watch Sagittarius A* with patient vigilance. Instruments across the globe monitor its emissions, hoping to catch signs of flaring or sudden activity. Each flare is not only a clue but a warning that this quiet black hole has the capacity for violence. The galactic center may appear serene from our vantage point, but in reality, it is a place of extremes, a cosmic crucible where the familiar rules of matter and energy bend under the weight of gravity. And yet, there is something deeply poetic about the stillness of Sagittarius A star. For all its power, it has allowed life to flourish here on Earth, far from its dangerous influence. If our galaxy's black hole were more active, flooding space with jets of energy, the delicate balance required for life as we know it might have been impossible. In this sense, the quietude of Sagittarius A* is not merely a scientific fact. It is a condition of our existence. Its silence has given us the space to emerge, to wonder, and to eventually turn telescopes back toward it in search of our origins. The future of Sagittarius A* is tied to the fate of the Milky Way itself. When the merger with Andromeda eventually takes place, our galaxy will be transformed. The spiral arms will be disrupted, new stars will be born in bursts of activity, and the central black holes will drift toward each other until they meet. The resulting supermassive black hole will be millions of times larger than even Sagittarius A*, a single, dominant presence in the heart of the new galaxy, sometimes called Milkomeda. Humanity will likely be long gone by then, but the physics unfolding in that distant future will be the natural continuation of the story we are only beginning to write today. For now, the task is to keep watching, to keep listening to the faint whispers that emerge from 93 million miles away. Every photon we collect from the galactic center is a message that has traveled across 26,000 light-years, carrying with it the imprint of a black hole that has shaped everything we see in the night sky. To gaze at Sagittarius A* is to see not only the heart of our galaxy but the essence of cosmic history itself, compressed into a single silent shadow. And as our instruments grow sharper, our theories more refined, and our imagination more daring, we will continue to peel back the layers of this mystery. Perhaps one day, we will find answers to the questions that now haunt us. What lies within the singularity? Does information truly vanish beyond the horizon? And what does the ultimate fate of Sagittarius A* tell us about the destiny of the universe as a whole? These are questions without easy answers, but they are the kind that keep us searching, that keep us awake at night, staring upward into the darkness and wondering what lies beyond. To stand beneath the night sky and think of Sagittarius A* is to feel the strange tension between intimacy and enormity. On one hand, it is unimaginably distant, 26,000 light-years away, a number so large that it defies ordinary comprehension. On the other hand, it is also profoundly personal, for every star we see, every orbit of our sun, every quiet night we spend on this planet is shaped by its gravity. Sagittarius A* is not merely out there in the depths of the Milky Way. In a very real sense, it is part of us, woven into the fabric of our cosmic home. This is what makes black holes so extraordinary. They are not simply destructive forces, not merely cosmic monsters devouring whatever dares to come close. They are engines of creation as much as they are agents of collapse. Without them, galaxies would not form in the ways they do. Without them, stars might not cluster into spirals or merge into clusters. Without them, the balance of cosmic structure would shift, and the universe would look nothing like the one we know. In their shadows, paradoxically, we find the light of understanding. Sagittarius A* embodies this paradox with quiet dignity. It is massive beyond imagination, yet invisible. It is violent in its physics, yet calm in its present behavior. It has no surface, no solid form, and yet it exerts an influence that stretches across hundreds of thousands of light years. It is, in every sense, a mystery that cannot be held in words alone. And still we try. Through mathematics, through observation, through metaphor, we reach toward it, knowing that the act of seeking is as important as the answers themselves. There is something deeply human in this quest. For most of history, the stars were enough. They were distant fires, guiding navigation, inspiring myth, shaping calendars and rituals. But as science advanced, we asked deeper questions, and those questions led us to places stranger than myth could imagine. We discovered that at the center of our galaxy, in the direction of the constellation Sagittarius, there is not a god or a spirit or a river of souls but a black hole, a place where space-time folds in on itself and the known laws of physics collapse. And somehow, this revelation feels no less profound than the myths it replaced. If anything, it feels more so, because it reminds us that the universe is richer and stranger than anything we could invent on our own. As we look toward the future, we know that Sagittarius A* is not the end of the story. It is a chapter, one piece of a larger cosmic narrative. The universe is filled with black holes, from the stellar remnants of dying stars to the supermassive giants at the hearts of galaxies. Each one tells a story of collapse and persistence, of destruction and creation, of gravity stretching reality to its limits. Studying them brings us closer not only to understanding the cosmos but to understanding the nature of reality itself. For physicists, Sagittarius A* is a laboratory. It is a place where general relativity and quantum mechanics collide, where our current understanding falters, and where new theories may be born. The quest to reconcile these two pillars of physics, the smooth curves of Einstein's spacetime and the jittering probabilities of quantum fields, may find answers in the heart of a black hole. Perhaps one day, by studying Sagittarius A* and its kin, we will glimpse the unifying principles that bind the universe together, a theory of everything hidden in the shadows of the event horizon. But for the rest of us, Sagittarius A* offers something different. It offers perspective. To know that at the center of our galaxy lies a supermassive black hole is to be reminded of scale, of time, of our fragile place in the immensity of existence. Our lives unfold in moments, years, decades. Yet Sagittarius A* has existed for billions of years, patient and silent, shaping the galaxy around it. To reflect on this is to see our worries in a new light, to recognize that we are fleeting, yet also connected to something vast and enduring. And perhaps this is the true gift of astronomy. Not merely facts or discoveries, but the humbling recognition that we are both insignificant and extraordinary, that in a galaxy anchored by a supermassive black hole, life has emerged, conscious and curious, daring to look outward and inward at once. We are the universe contemplating itself, the cosmos becoming aware of its own hidden structures. Through us, Sagittarius A* is not just an object of gravity and shadow. It is a mirror, reflecting our own longing to understand. When future generations look back, they may remember the first blurry image of Sagittarius A* as a turning point, the way we remember the first steps on the moon or the first glimpses of Earth from space. Not because the image was sharp, but because it was proof that we could imagine the impossible and then make it real. That even in the face of vast distances and impossible physics, human beings could stitch together telescopes across the globe and catch a glimpse of the unseeable. It was not just a scientific achievement, but a human one, a testament to curiosity and collaboration. And so, the story continues. Sagittarius A asterisk will remain at the center of our galaxy, silent and steady, long after we are gone. But for now, in this brief moment of cosmic time, we are here to witness it, to study it, to give it meaning through our questions and our awe. In the end, perhaps that is the most remarkable thing of all, that a species born on a small planet, orbiting an ordinary star, could look across 26,000 light-years and glimpse the heart of its galaxy, and in that heart, find not only a black hole but a reflection of itself. So the next time you step outside on a clear night, look up at the river of stars stretching across the sky. Know that at its center lies Sagittarius A asterisk, the silent guardian of our galaxy, a shadow around which everything turns, invisible yet essential, terrifying yet beautiful, a reminder that in the vastness of the universe, there is always more to learn, always deeper mysteries to explore, and always a reason to wonder.